Ever since Galileo first looked through his telescope and spotted moons on Jupiter, astronomers have been wondering what they might find if they could look further into the night sky. As we progress in our understanding of the universe, one of the many intriguing mysteries is whether or not there is life out there beyond Earth. Fast forward to the 21st century, and we have now built instruments such as Kepler, which over its lifetime observed over 500,000 stars and discovered more than 2,000 planets outside our solar system. These planets are otherwise known as exoplanets. Today we have more than 5,000 of them, and the number is rising fast. Theoretical calculations suggest that there are around 300 million potentially habitable planets in the Milky Way galaxy alone, and several habitable Earth-sized planets within our 30 light-years of Earth, essentially humanity's galactic neighbors. So, one cannot help but wonder, is there life in any of these worlds? Natalie Patala is a professor of astrophysics at UC Santa Cruz, and one of the first scientists in line to use the James Webb Space Telescope in her search for other planets in our galaxy. If there is life elsewhere in the universe, she could be the one to lead us to it.
So when Webb was constructed, we were only beginning to learn about other worlds orbiting other stars. Today, we have over 5,000 known planets orbiting other stars, and we have many surprises that were revealed over these last 2.5 decades. And now we are literally knocking on the door of a new epoch of exploration, which is the study of exoplanet atmospheres. And it's going to give us a new lens on their diversity. Webb is a spectroscopic machine. We're going to be looking in color space. But what we're also going to be doing with Webb is collecting light from astrophysical objects like exoplanets, spreading that light out into a rainbow and looking at that rainbow with very close scrutiny. And that will allow us to see the chemical fingerprints that an atmosphere leaves on the light. For exoplanets with Webb, what we're going to do, we're going to observe them in many different ways. But one of the primary ways is to observe the star when the planet is transiting across the surface. And when that happens, this very thin layer of the atmosphere will intercept some of the photons from the star on its way to our telescope. And then we will spread that light out into a rainbow and disentangle these chemical fingerprints from the atmosphere from the chemical fingerprints of the host star, for example.
How do scientists search for signs of extraterrestrial life? On Earth, life leaves telltale signs in the atmosphere. Photosynthesis is ultimately responsible for the high oxygen levels in the thick ozone layer. Microbes emit methane and nitrous oxide into the atmosphere, and seaweeds emit chloromethane gas. These chemicals, when present in sufficient quantities, are indicators of life and are known as atmospheric biomarkers. Detecting them in any atmosphere of the exoplanet should, in theory, be a means of discovering whether life exists on any alien worlds. A question that boggles the mind of many today is whether we can detect concrete evidence of alien life through the use of the James Webb Space Telescope.
Webb was not designed to be a life finder. And we have a lot to learn before we start looking in earnest for biosignatures, these signatures of life imparted by life that has actually taken a global toehold of a planet and influenced the atmosphere in a global way that's remotely detectable. Kepler uncovered this diversity of planets. One of the things right out the gate that Kepler discovered is that the most common type of planet in the galaxy orbiting in the inner solar systems is a type of planet we don't even have in our solar system. You know, in our solar system, we've got the tiny rocky things orbiting nearby. We've got the big giants orbiting far away. But in the galaxy, it turns out that the most common type of planet is something in between. And we don't know what its nature is. It's been suggested that a large fraction of these planets started out as something like Neptune, but in the dynamical formation and evolution processes of planetary systems, those planets could have migrated inwards towards their host star. So what happens if you take a Neptune and you plunk it down in an orbit like Earth's? What's going to happen to it? Well, scientists say that what happens to it is the hydrogen envelope gets completely stripped away, leaving a rocky core. So rocky cores are great for life, right? Is that a potential abode of life? Does that broaden the number of landscapes available for life in the galaxy? We don't know. So we want to understand that mysterious population that we don't have in our own solar system. And in doing so, by looking at the atmospheres, we will have diagnostics that allow us to understand all of the physical processes that sculpt a planetary atmosphere and leave something after 1 billion or 2 billion years where life could or could not take a toehold. What I really want in order to be able to see biosignatures is I want all of the light that's reflecting off of the surface of the planet. And in order to see that, you need direct imaging. So we want a telescope that is capable of very accurately blocking out the starlight, as if you were holding up your thumb in the sky and you could block out the starlight so that you could see the very faint planets reflecting and emitting light in orbit around that star. And you have to do that very carefully because those planets are about 10 billion times fainter than the star that they orbit. But once we can do that, we will have more photons that we can collect. We will play the same game. We will spread them out into a rainbow and we will scrutinize those features, those chemical fingerprints in the light. But with a bigger telescope that has higher sensitivity and very good star suppression technology, we will have the capability of detecting biosignatures like oxygen from photosynthesis for dozens of planets.
Astrobiologists explore several other techniques that might detect signs of alien life. Continuous technologies are being developed in order to better facilitate this detection process, which makes many scientists confident that we will detect life out there in the next few decades. No, they are not talking about intelligent life, although that would be mind-blowing in itself.
Every time we look outwards and push frontiers, we always end up turning inwards as well. As we look for life beyond the solar system, we have to consider the conditions under which life could arise in order to pinpoint the most likely abodes of life. So we consider the extremes. And when we do that, we learn something about the sustainability of life right here on planet Earth. Humans have been asking the question, are we alone since the dawn of time, since humans first existed, since the first human looked up at the sky and wondered what was out there, or saw a parallel between those faint points of light and our own sun. So I think that looking up into the sky and not feeling that existential cosmic loneliness, but knowing that every point of light you see is not just a star, but a planetary system, abounding with life, that is going to fundamentally change how we see our place in the universe.
While some people believe that the extraterrestrials, with their advanced technology, may be able to come here or have already visited us, this is not a popular idea among most scientists. This is a domain where the Search for Extraterrestrial Institute comes in. SETI Institute is the only research organization solely devoted to searching for and studying life and intelligence beyond Earth. Scientists here conduct experiments to look for proof, not merely of life elsewhere, but of intelligent beings in other star systems. There is a problem, however. So far, scientists have found no convincing evidence of biology beyond our home planet. Many people are convinced that after 6 decades of searching, the fact that SETI researchers have yet to pick up a signal from space is perhaps the most compelling evidence that Earth really is the only place where intelligence has arisen. But there's a more reasonable explanation for the fact that SETI receivers have so far heard nothing that's clearly extraterrestrial. Namely, the experiments have simply not examined enough of the sky. Or perhaps the antennas don't have enough sensitivity. Or maybe they've not been tuned to the correct frequency. However, the real reason that SETI has yet to find any convincing signals might only become clear once we've detected something. Nonetheless, SETI researchers are confident that it's just a matter of time until we discover a signal proving that intelligence exists elsewhere. So, if we are lucky enough to find and confirm an alien signal in our lifetime, how would the world react? The social implications of establishing the existence of extraterrestrial intelligence would be hard to gauge, of course. Such a discovery would immediately demonstrate that life is a process that begins on many worlds, and that evolution to intelligence has non-zero probability. Ideas that, as of now, are no more than an appealing hypothesis. Thanks for watching. Did you like this video? Then show your support by liking, subscribing, and ringing the bell to never miss videos like this.